Alright, welcome in everybody. Thank you for tuning in this evening. Just getting things figured out here. Who we got in chat tonight? We got Matthew in chat. How's it going, Matthew? Cecilia's in chat. Hello, Dr. Evans. How's it going, Cecilia? Good to see you in here. Alright, we are gonna get this music out of here, and we are going to talk about some weather. We got an interesting event here lined up with a recent storm event that worked its way through Wisconsin not too long ago. I'm sure all the weather folks in chat tonight are going to be well aware of the impacts that this event had. Just getting some last minute little things set up here and you'll be able to see the screen. Let's see, where's remote access? Alright. There we go. Alright. So we will get these slides rolling and then switch things on over. Hopefully if all is working right, y'all should be seeing us on the sides of your screen there. We have a special guest with us this evening on a special edition of Wisco-Weather. We have Dr. Clark Evans from the University of Wisconsin-Milwaukee. He is here with us tonight, and we have an interesting show lined up for all y'all this evening. We're going to be looking through a recent severe weather event that kind of worked its way through Wisconsin. But before that, we have some introductions to go through. Dr. Clark Evans, he's an atmospheric scientist at UW-Milwaukee, and he will be beginning work at NOAA later this July, and he participated in the 2024 Spring Forecast Experiment. Dr. Evans, how are you doing this evening?
I'm doing great, Charlie. How about yourself?
Doing quite well. I'm enjoying the nice, hot, humid weather that we have with the scattered thunderstorms we had yesterday.
Absolutely. I love this time of year. There's no better place than Wisconsin in the summertime.
Mm-hmm. Best weather in the world, as long as it's not 90 degrees with 89 dew points.
I kind of like that 90 and 89 every so often. Maybe not every day, though.
Mm-hmm. But moving right along here, we have some weather to discuss. On May 21st, 2024, we had a large severe weather outbreak that occurred across Iowa, Wisconsin, Illinois, Missouri, all across the Midwest experienced some type of severe weather. As you can see with those severe weather reports, see multiple tornado reports that occurred out in Iowa. Lots of storm chasers were down in southwest Iowa on that day, getting footage of the very incredible Greenfield, Iowa tornado with the multiple vortices going through that wind field. I know a lot of those videos circulated through social media. And also Wisconsin experienced its fair share of severe weather with some significant wind reports, some reports up to 100 miles per hour as these storms made their way through southwest Wisconsin and pushed eastward throughout the evening. I was set up chasing this day, and the forecast was slightly challenging. This was the forecast objectives that I had. Basically, what I was looking for was clear live pictures of the storm structure, because this was my first time really live streaming a major severe weather event, so making sure that that live stream was clear, working, was very, very important to me. Live images of the storm hazards, whether that be straight line winds, hail, or even the potential of a tornado or two, I want to be sure that I was in a safe spot where I can get those images, and also video of the storm impacts for news packages, just making sure that I was in a safe place where I could clearly get those shots for any interested news parties who were involved with that day. But moving into the 5 days out, this is where the forecasting process really started to pick up a little bit. On the GFS ensemble, basically with this model is what they do is they take the GFS and they slightly tweak the initial parameters so you get multiple different outputs for a given day. And this was some of the averages that we had for the May 21st, 2024 event. You can see it had that troughing pattern with that mid-level flow, with a little bit of some enhanced wind speeds there. And this is kind of the general shape that you'll see within the models for disturbed weather pattern. Same thing with the GFS. GFS was slightly stronger with that trough, and that trough ejected straight through Iowa, Wisconsin, throughout the Midwest, which started giving me the inklings that, okay, we may have some severe weather on the way. And I know Dr. Evans had his eye with the spring forecasting experiment, going through some new parameters that were put in place, being practiced and tested for this day to make sure that they could be used effectively in the future when they're eventually implemented.
Yeah, for sure. I was there the week before this event down in Norman, Oklahoma, sandwiched between the National Weather Service in Norman and the Storm Prediction Center. And so in the time that we could look longer out, like 5, 6, 7 days out, we saw, oh, there's the potential for something big coming down the line in the central US, somewhere around that May 21st, 22nd period. And so some of the tools that they were looking at to see how well they could be used in the forecast process, like you and I, when we were talking about this event, Charlie, we talked about pattern recognition. Like you showed those 500 millibar charts that give you that look of, all right, I know that this type of pattern gives you something severe-wise, at least a threat somewhere in the Midwest. We've got a lot of new models based off of AI, artificial intelligence, coming down the pipe, run by companies like Google or NVIDIA or Huawei, the big Chinese tech giant, that are basically large automated pattern recognition models. They feed in a ton of data from like 30, 40 years of archives and use that to create forecasts of the weather. So what I have here, these 4 panels on the left, the top on the left is Google's GraphCast, the upper right is Huawei's Pangu Weather, and the bottom left is NVIDIA's ForecastNet, 3 of the leading artificial intelligence models, looking at that 500 millibar pattern. And then the GFS that you showed is here in the bottom center of the diagram. And they all have broadly similar patterns. You can see a shortwave somewhere near the Great Lakes in each of the AI models. It's a little bit further to the west in the GFS, which was closer to what actually happened that day. But they all show some measure of faster wind speed coming into somewhere in the Midwest. And ultimately, the dots that you see here are what actually happened on that day. So the AI models give us more possibilities. Like you mentioned, the GFS ensemble, you take the GFS, you run it 20, 30 times, and you get 20 or 30 possibilities. These AI models, you and I could run them on our computer and probably do 1,000 in like an hour. They run so quick once they've been trained. So if you now have more of the range of possibilities, you can better hone in on what is likely or not likely to occur. But those aren't the only ones that were being tested. You can take models like the GFS ensemble or like a high resolution model like the HER and run a model like that out 5, 6, 7, 8 days in advance. And you can get storm attributes at those longer lead times, not just the day of or maybe the day before, but out to longer periods of time. So these 2 columns here on the left are forecasts utilizing the standard SPC coloring scheme. So like that brown is 5% probability, yellow is 15, red is 30. The pink here is going to be the 45, and then the purple being the 60. You can take the GFS ensemble, throw a bunch of parameters in it, and say, all right, whenever you've had these parameters, what have you gotten severe weather-wise? And based off of all that training, you can then apply it to any event in the future. And so even 6, 5 days out, the GFS ensemble, these 2 different formulations of these AI tools, were really highlighting the Midwest, very close to what actually occurred, as having really high probabilities for severe weather, total severe in this case. The ones based off of the explicit storm attributes weren't quite as bullish, but they still, as you move from day 6 to 5, you see that yellow contour come up in here and some of the 20 or 25%. That's still more than what we see regularly up here during the month of May. So it's at least situational awareness to say, all right, the models are starting to hint at something here. Maybe I need to keep my eye on it. So there's lots of tools that the forecasters at the Storm Prediction Center are using or testing to be able to help improve the quality of their outlooks, even all the way out to 8 days in advance.
Yeah, I know for me, forecasting that far out, I'm not really too focused on specifics. I just want to get a general picture of like, okay, we have this system that's coming through. Here's kind of a broad brushstroke of where that severe weather potential might be. And hopefully with those new models like you were showing, maybe we can narrow things down a little bit. Like, okay, this is kind of the broad picture of what things look like right now. Maybe here within this outlook based on the AI model, there might be increased probability in this region or in this region, and seeing how those kind of adjust as that forecast goes along.
Yeah, absolutely.
But 4 days out is when the Storm Prediction Center added their 15%. And 3 days out was when we had that 30% increase. So now it's things are starting to step up a little bit. Like, okay, we've got a good handle on this event. We're 3 days out. We have confidence of severe weather within this risk area. And 2 days out was when that enhanced risk was added. Just looking at the NAM at that range 2 days out, you can see that strong trough is still there, ejecting through the Midwest with Wisconsin, Iowa, Illinois, Missouri kind of right in the crosshairs of this storm system. We had a lot of fuel for those storms too at this range shown on the NAM here. I know the NAM can be a bit bullish at times with its instability outputs just because it tends to run a little bit more on the moist side. But I feel like at this range, it still had a pretty good handle on what actually happened that day. You can see we had our warm front draped here with around 3,000 joules per kilogram of CAPE in southwest Iowa, and 2,000 to 3,000 kind of scattered throughout the rest of the warm sector. And on top of that, it was also showing a lot of wind shear for these storms too. And for all you guys in the audience who may not be as versed with some of the parameters here, wind shear is basically the turning of the air with height. So as you increase in altitude, the direction of the wind changes. And we have storms in those environments. Essentially what can happen is as the storm goes up, that storm is going to change direction as you move upward. And that's how you get rotating thunderstorms known as supercells. And when you have supercells in these unstable environments, things can get pretty nasty severe weather-wise pretty quickly. Just kind of a broad overview of the environment at this range. We had our low pressure here, cold front draped from Iowa down through Oklahoma, and that warm front extending across the Minnesota-Iowa border, central Wisconsin, and then out into Michigan. I know a lot of storm chasers at this point had their eye on southwest Iowa, trying to be right on the surface low for the greatest tornado potential, but I had my eye on the warm front here for my storm chase.
Yeah, and so these artificial intelligence tools that I introduced earlier aren't just good at like days 5, 6, 7, 8. They can extend all the way into the present as well. And so I threw up the ones from day 3 here on the top row, and then the bottom is what actually verified. The PP is for practically perfect. Basically says if you knew where all of the severe storms and reports were going to occur, this is the forecast you would have drawn. And it's what the SPC uses to verify their forecasts. All of these tools, whether they're based off of the GFS and taking parameters like the shear and the CAPE and the SIN into account, or if it's based off of those plus explicit storm attributes, in each one of these, you can see a pink contour, 45% coverage of probability contour for severe weather out at day 3. That's quite impressive. And you can even see here on this product on the left, one of the GEFS-based products, there's a 60% contour here from eastern Iowa into north central Wisconsin. So all of these models had that whole area, especially the eastern 2/3 of it, sort of I-35 in Iowa and east, highlighted as this has some real big potential. I'll note too that while we're here, you showed the day 4 and the day 3 SPC outlooks. So right now the SPC day 3 is just a total severe outlook, but they're looking at increasing the specificity of that in the next year or two to also cover the individual hazards of tornado, wind, and hail, just like the day 1 and 2 outlooks do. And then that day 4 outlook, that's either that 15 or that 30%, they're looking at extending the total severe, this enhanced, slight, moderate, high, et cetera categories for those forecasts in the next couple of years as well. So again, providing more specificity at longer lead times to be able to help with this situational awareness, that preparedness that you could do. Now there's something down here on these bottom diagrams, this hatching area. I'm going to come back to that in a little bit. It's not the hatching, for those of you who are really familiar with SPC outlooks and you know that SIG severe hatching, this isn't quite that, but I'll leave that as an appetizer. We'll talk more about that in a few minutes.
Yeah, and with those new AI models, I know sometimes the general public can get confused with the Storm Prediction Center outlooks. You have the typical high, moderate, enhanced, slight, marginal, and general thunderstorm that we use on the day 1 to day 2, and I know day 3 can be slightly different. I don't believe they issue highs for day 3. I think it only goes up to enhanced, I believe is the highest that they can go, or maybe moderate.
Maybe moderate.
But yeah, I know just having those different categories for the day 1 through day 3 range can sometimes confuse the public. Like, okay, we have this at day 3, and now all of a sudden at day 2, it's taken up a notch. So with these new models, maybe we can help kind of level things out a little bit so the public isn't as jarred by all of a sudden like, oh, the severe weather outlook for today just suddenly got upgraded from an enhanced to a high.
Yeah, there's so much that goes into those types of decisions. The forecasters and management fret over any sort of jump upward or even drop downward. And to see 2 category changes like enhanced to high, it's just so rare because of that public impact that it would have, even if it's warranted.
Yeah, hopefully with these new tools that can be leveled out a little bit so it's a bit more steady with those upgrades, so the public is caught a little bit less off guard, and so the weather community can hopefully more accurately convey kind of what's going on within that timely manner that we hope for.
Yep. And yeah, so there's also those longer range storm scale models. I forgot that I still had this in here. It's like running those per type of models out to, in this case, this was 84 hours. And all of the coloring that's in here is updraft helicity, that measure of mid-level rotation. So it's basically, where does the model think that there's a rotating storm or a supercell present? The higher the values, the more strongly rotating it is within the model forecasts. And so usually once you get above 75 or so, it depends on the specific model, but generally 75 in that ballpark or higher is an indication of, all right, the model's got something that's kind of rotating enough to think that this might be capable of producing severe hail or maybe a tornado. And then you get 150, 300, 500. These are really intensely rotating storms. This helps to show that the models are capable of showing what could happen on that day. And broadly speaking, they had the same idea. You see these long tracks of these purples and these reds indicating discrete supercells moving for hundreds of miles in some cases. They just weren't in agreement on where that would be. Would it be back in Iowa or even southeastern Nebraska, closer to that surface low? Or would it be further to the north and east as that system started to eject further to the north and to the east? So even though the broader tools, the AI tools that took in environment information and maybe storm attributes, they covered all of that area. When you get down to the nitty gritty at this day 3 range, there's still disagreement on specifically where the storms might be most severe, which leads to uncertainty, leads to conservatism in the forecasts. So you wouldn't see SPC take this information and be like, oh yeah, day 3 moderate, I gotta go the highest that I can go. There's still uncertainty in that, but there's these tools that can help them better understand what that uncertainty is to then be able to communicate that to the public and just inform them of, all right, here's why we've gone this way. And we didn't have these tools, or at least so many of these tools, until the last few years.
Yeah, I know these tools, especially since this last, May 21st event, there was some uncertainty, especially with the Wisconsin side of things, just how storms would evolve along this warm front. So it's interesting to see the different outputs from these 2 models kind of handling that uncertainty and guiding forecasters along.
Absolutely.
But we're 1 day out now, and that moderate is finally added in there. And at this point is when the weather community starts doing what they're doing, and they're taking this and they're running with it. And so was I, especially when you have a moderate that close to home. I'm thinking, okay, we're starting to gear things up a little bit more. 1 day out, you can see that I was still focused on that warm front. Essentially at this range was when the convective allowing models started to come in a little bit. This was the 0Z HER the night before, showing a line of storms moving through in the early afternoon, and then that bigger complex of storms moving through in the evening. So at this point I'm thinking, okay, for my mission to provide live storm coverage to my audience, which is mostly situated in Wisconsin, I'm probably going to want to be chasing locally on this day just so I can kind of get the best coverage that I can possibly have with the multiple storms rolling through, so that folks can kind of see what's going on, and then kind of making sure that everything's situated and ready to go.
Yeah, for sure. And so to dovetail off of that day 2 outlook that you provided, getting in the day before there with that moderate risk, sort of like Des Moines, east of the Quad Cities, and the enhanced extending almost to Green Bay and Wausau and Eau Claire. They also had these hail, tornado, and wind probabilities associated with them. The wind threat was perhaps the highest, a 45% contour corresponding to the moderate risk area. So some thought that there would be wide coverage of higher probabilities of winds. But hail, this 30% red contour here, nothing to sneeze at. And then this broad 10% tornado area here in yellow in the upper right. That doesn't happen around here, but just a couple of days each year on average. And so seeing these 3 categories here, it's like, okay, there's something to this event. But you look at that moderate risk, it's like, okay, moderate risk. A lot of people tend to think, and you and I were talking about this yesterday, moderate often conveys a higher severity associated with it. And the hatching that you see in the hail, the wind, and the tornado does suggest that is warranted for this case. That hatching is that significant severe or sig severe. So a higher end tornado, larger hail, stronger wind. But formally, that moderate risk or that enhanced risk doesn't convey or shouldn't convey anything about severity. Like you could have a dry line day in May in Texas where there's probably going to be capping all day long. If any storm forms, it's probably going to be one storm. But if that one storm forms, it's probably going to drop 3-inch hail and be a really damaging event for wherever it hits. Your coverage, your probability is going to be really low. That might be a marginal risk type of day. But if that verifies, you probably want to convey some form of severity. And right now, the way they do things, they believe doesn't really convey that as well. So they're working on this thing called conditional intensity guidance to kind of separate out that marginal slide enhanced moderate, 1, 2, 3, 4, 5, as well as the expected severity. So this table here, these 2 left columns are if you don't expect it to be particularly severe. And 160, 180 days, that's 340 days per year where you would not expect this higher end severe. But then you get this hatching, what they call SIG 1, category 1, where significant severe is possible. It's going to have that higher end cape, higher end shear. You'd expect tornadoes and hail out of supercells, and you'd expect a squall line with bowing segments if you're looking at wind. That's about 20 days per year. That hatching a few slides back when I showed the forecasts for 3 days out and what they verified is, that's what that was indicating, that there were all of those significant wind reports that occurred in southern Iowa in particular, and that would have been the definition of this first level of hatching. But then there's this double hatched, where this is the cream of the crop of the higher end severe events. So extreme cape, very strong shear to go along with it. Discrete supercells, you're definitely expecting that. Potential for really large hail, EF2 plus tornadoes. And for wind, you're looking at a well-organized MCS or a derecho. This is a 5-day per year. You're expecting big impacts over a fairly widespread area, not just from individual storms. And so they think that once they get this in place, probably within the next year or 2, it'll really help be able to hone in those outlooks to say, here's what we expect in coverage and the probability with that, and here's what we expect the associated severity to be a little bit better than the way that the current outlooks do that now. Mm-hmm. So for instance, if you're looking to go out in the field, Charlie, and do some reporting, like this would give you a little bit better guidance than they are able to now of what they expect for storm mode and potential severity that could help hone in like, all right, I don't want to be in the most severe area. I want to capture something that's a little bit less severe, but probably more open and maybe I'd have more ownership of it. This could really help with refining some of those types of decisions.
Mm-hmm. I know there have been some days in the past, like in 2016 and 2013 with the Bennington tornado in 2013 and the Chapman, Kansas tornado in 2016. Those were, the Storm Prediction Center kind of had those lower end outlooks for those days. But what happened was you had really substantial supercells that produce really long tracking, intense tornadoes. And I feel like these kind of outlooks would better refine those probabilities so that not only the public but meteorologists are more tuned in, like, okay, we have this really, really volatile environment. We're no longer basing it off of the coverage of storms based on what the old Storm Prediction Center outlooks were. We now have this new tool that can better convey some of the potential for more significant severe weather.
Yeah, absolutely. That's the hope. That's the goal. They've been working on it for a few years now. I think they're getting pretty close. Mm-hmm. And so you can see that a little bit in these outlooks. So the people who were in the spring forecasting experiment that week, they actually put together their own day 2 outlook with this new approach and their own day 1 outlook with this new approach. And here on the right-hand side is what would have verified for the severe reports between 18 and 12Z on that day. And so in this day 2 outlook, you can see this red 15% contour. This is for a tornado forecast. So they had elevated probabilities for tornadoes here, but you can see this single hatching extending from like Kansas City through the Twin Cities almost to Eau Claire. And then this double hatching in the western 2/3 of Iowa. So that southwestern play that you were talking about earlier, Charlie, the forecasters this day are like, oh, we see stuff here that suggests that there's going to be discrete supercells with long track intense tornadoes covering the western 2/3 of Iowa. The next day, they didn't think quite so bullish, and in fact, they shifted all of that further to the east, so kind of I-35 and east. And then this salmon-colored contour is the 20 or 25% contour, but kept the single hatchings. It's like, all right, we think that there's going to be discrete supercells with tornadoes, relatively high coverage. Severe, yes, but maybe not like many EF2 plus tornadoes over a large area, like a few EF2 plus tornadoes over this particular area. I don't think there were all that many. There were a couple of really big ones further west in Iowa, but there weren't that many as you got further to the north and east. There were a lot more wind reports on that day. But that's the type of information that these new outlooks that we tested. It was really cool to actually be on the forecaster hot seat, creating these outlooks alongside an SPC forecaster and facilitators that you could then verify the next day and look at all of the tools that you use to create the forecast and evaluate those as well, giving them hard feedback to help them know, all right, how can I make things better for the future, and then straight into SPC operations.
Mm-hmm. Yeah, I know the Storm Prediction Center's outlooks kind of were, leading up to the event, they were kind of bouncing around a little bit with the just kind of how broad the severe weather potential was for this day over such a large area, and honing that in can definitely be beneficial in the future as these tools are implemented for forecasters to use in the real world.
Sure.
All right. Well, here we are. We have arrived at the day of the event, and we have our big moderate risk area extending in southwest Wisconsin, across Iowa, portions of Illinois, and Missouri. I was still watching that warm front, and we did have that morning line of thunderstorms that the HRRR run had the day before. The HRRR at that range can be a little bit iffy with timing, and this was a clear example of that, as that storm was much, much farther to the west than that model had outputted. But this line of thunderstorms, as it moved through Iowa in the morning, it did leave behind an outflow boundary within the target area that I'd kind of been eyeing. And that outflow boundary did kick off a few isolated storms within that environment. Typically on these higher end days, those isolated storms that kind of fire up a little bit earlier, a little bit ahead of the main line, can sometimes be the show of the day. This was the storm that I picked up as it approached Wisconsin, kind of crossing over the Iowa border near the Platteville area. We had some elevated storm structure at this point. This storm was more of a hailer as it moved to Wisconsin, as it kind of lost steam. This cell was actually this storm down here, so it covered quite a distance on its trek over. But that elevated storm structure, for me, I'm not seeing a huge tornado threat with this storm. This one's going to be more of a hail and damaging wind risk. But as the evening went along, storms did increase in coverage. We had more of a line of supercells set up in southwest Wisconsin, and these storms did have tornado potential. As you can see, this was the first tornado warning of the day that I ended up on with our area of rotation on radar just off to the the northwest. And from a storm chaser, this was the view I had of that storm. And it's not the greatest for what my mission was. You can see we're down in a valley between lots of hills and lots of trees. And the storm mode at this point, because they were transitioning from isolated cells to a more linear storm complex, things had started to become filled in with rain, really hard to see what was going on. And that especially continued as this massive complex of storms with all of these tornado warnings scattered about started marching its way towards the Madison area. At this point, I'm thinking, okay, the mission that I have right now of getting close-up, high-quality, clear footage, I'm not going to be able to do that. I'm going to try to get out of the way of this thing a little bit because these were cruising up my way at 65 miles per hour. I want to get past Madison so I'm not stuck behind the storms. I want to shoot east down 94 so I can stay ahead of this by using the highway system. And that was the play. We ended up shooting way to the east, getting far ahead of the storm, and documenting it near the Oconomowoc area as it pushed through with some of those higher winds.
Yeah, that was the day to abort that late at night. And that area southeast of Spring Green, that's such a beautiful area toward the driftless region, but it's so hard to chase because of all those hills and valleys and trees and everything. What makes it so beautiful is what makes it so hard to chase.
Yeah, that's how it is in Wisconsin. You love all the rivers and lakes and the nice hills in the summertime, but when it comes time to chase, like, oh, I wish I was in the plains where it was all flat and open. I could see everything.
Yeah, for sure. I've only chased Wisconsin a couple of times, but each time I'm like, yeah, I wish I could see a little bit better. But such is life. But so on days like this, some of the radar images you had show like these red and yellow outlines, not just for the warnings, but the coarser ones for the watches that SPC issued on that day. And what you see here on the right are the watches that SPC had active at 0 UTC, so that's 7 p.m. our time on the 21st, extending from Green Bay and Wausau all the way through Missouri down toward Oklahoma and Arkansas. The red meaning tornado watches, stacked one on top of the other. You can take machine learning tools as well. The HREF, if you go to the SPC's website and look at some of their ensemble forecasts, that's what you'll get from there. It's a set of 7 or 8 models that they run that can represent storms, and they give out environmental parameters and things of that nature too. You can feed that into machine learning tools and get out what it thinks you should have in terms of a watch box. So at this time, all this red area is where the machine learning algorithm with the model input thinks that a tornado watch was likely warranted. And then blue to the north, north of Green Bay, Wausau, toward the Twin Cities. And then here in central Missouri is where it felt that a severe thunderstorm watch was warranted. And everywhere in white is where it didn't think one was warranted at all. So instead of just having these static watch boxes that get issued for hours on end and then maybe get cleared from the backside, one of the visions for the future is to have progressively moving watches over time, so that an area is either in a watch or is not. It's not necessarily in watch number 691 until it gets cleared by the National Weather Service. And in addition to that, there's other cool tools that they can use to help refine those day one short-term forecasts. Or if you're out in the field and you're wondering, where should I be targeting? Some of these tools really help hone in on that. So on social media, Twitter or X, you may have seen NATOcast. That's a tool that SPC is evaluating. It's built by a computer scientist who's thrown a ton of data at it. Said, all right, based off of whenever these data parameters have led to severe weather, here's what I think the forecast should be. And on this day, that NATOcast forecast from 7 a.m. in the morning, it's like, this is a 60% contour in purple for wind, 65, 70, 75, 80, 85 in the middle. SPC doesn't forecast 85% contours, but it was really, really aggressive that there would be severe wind across northern Illinois into Wisconsin that night. This is 4 UTC, so this is 11 p.m. in the evening. This WAFS, and we'll come to this again in just a moment, Warn on Forecast system. This is a special, really high resolution, 1 kilometer grid spacing ensemble forecast system that they run every 30 minutes during the peak of severe weather season on severe weather days that provides a ton of output of storm attributes. And you can throw that into machine learning algorithms as well. And those storm attributes and environmental characteristics, this pink contour is at 45% wind. You can see 50 in here. It's not quite the same as the NATOcast forecast, but it's still really highlighting that corridor north of St. Louis, up toward Green Bay, up toward Eau Claire, as having quite elevated possibilities for severe wind. And that's ultimately what happened. Here on the right-hand side is the verification. You've got that 60% contour in western Wisconsin toward the Quad Cities, and enough significant wind to have led to that hatching there, centered on the Quad Cities, more or less. And then one more thing, so that Warn-On forecast system, really cool cloud-based swaths. If you just search CBWOFS online, you'll be able to get to the output for this as well. You can search through days from late April into early June. This is an example. This is looking at 7 p.m. Our time from a forecast initialized at 6 or 6:30 p.m. our time on the 21st. This is looking at individual storms that the ensemble is predicting and saying, all right, with this storm, what's the likelihood of it producing at least one severe wind report here on the left? Or what's the maximum or the probability of having severe winds here on the right? And so here, this storm, this line that it's showing is saying, all right, there's at least a 65% chance there's going to be at least one severe wind report out of this. You see 40, 55, 60. So a number of different storms up and down the line here with elevated probabilities of producing at least one severe wind report in about a 30-minute period. And then here on the right, you can see why, because the ensemble is predicting explicitly fast winds, over 50 knots. These reds, every ensemble member was predicting winds, severe wind out of these storms as it progressed to the north and to the east. And then I think I got one more here. So this one here is looking a little bit later, 8:30 p.m. So a little bit later than the time that you have here, but still roughly in the ballpark. You can see this shading here. So this is ensemble, what it thinks in terms of that mid-level rotation, where it thinks there's a supercell with the potential for producing a tornado. You've got your tornado warnings over and just west and northwest of Madison. The model had this track in here with elevated probabilities of strong rotation, at least at mid-levels, extending through Dane County up toward the west end of Lake Winnebago. So with this forecast issued at 6 p.m., you'd get the output at about 6:30 p.m., give or take. You're like, all right, I got storms up and down the line. Which one or ones are going to be the ones that I want to track? You can take a tool like this and say, all right, this is what the model thinks, and see how that's evolved over the course of a few runs, and then feed that into your thinking, what you've seen pattern-wise, what you're seeing in the sky right then and there, and make perhaps a more informed decision to target this storm as opposed to a different storm. So it's really cool what the models have become capable of doing more often than not, even at these really short ranges. When you've got storms in there and can really put those into the model, it can do pretty well. I think they've been showing stuff from the Greenfield tornado that it gave them several hours of lead time for that. So it's just really cool to see what's coming down the pike.
Yeah, I've known NATOcast when that was kind of first put out on Twitter. It was kind of like, became a little bit of a running joke, like, okay, storm chasers this day, the NATOcast is at a 15% with the significant hatching, so storm chasers go this way. And I actually have a funny story with the NATOcast where last year, the picture of the tornado that I used in the thumbnail for this live stream, the thing that put me onto the tornado potential for that chase was NATOcast. This was the day that the Storm Prediction Center added it to their HREF page online. If you go on there, it's somewhere in their list of products, and I was just kind of messing around with it, scrolling through with it that day, not really expecting any severe weather. And I saw the little 2% contour over Janesville. I was like, oh, okay, maybe I had nothing going on that day, so maybe if something interesting looks like it's going on, maybe I'll work my way down there. It's only an hour drive. Might as well, wouldn't hurt to go take a look. And what ended up happening is we had a supercell organized near Madison, and it produced a tornado right within the bullseye of that 2% contour. So to see these tools kind of come along the way that they have is really, really interesting. I'm excited to test these out in the field too when they eventually become available.
For sure. And yeah, they're great tools, and I will emphasize tools. They'll never be a complete replacement for human intuition, eyes in the field, because the models will never know everything that's happening in the atmosphere. And even if they did, they'll never be able to represent it perfectly. So they're really great tools to help you hone in on a feature or an area to then apply your expertise, your intuition to come up with an even better forecast, rather than having to try to do that over a really large area and run out of time or run out of processing capacity in your brain to do that. So it's cool. And that's a really interesting story with NATOcast there for you getting that storm near Janesville.
So yeah, all the storm chasers in chat right now, thankfully, as of right now, AI isn't taking over us completely. We still have a ways to go before we have AI-driven storm chasers out there driving around in their cyber trucks.
Yes, so I don't know if any of us want to see that day, but since you mentioned that, it's really cool. One of my colleagues at UWM, Professor Rober, he worked with a grad student who's still around, Alex Moxon, on utilizing AI to simulate storm chaser behavior for the 2013 El Reno tornado. Putting in a representation of Oklahoma with the grid system and a hypothetical storm like the El Reno one. What should people have done? What did people do? Like, how did it lead to ultimately what we saw with that day? So it's kind of cool what you can use AI tools for, because we don't want to put a tornado in El Reno and have the damage that it causes. But if you can put it into one of these AI systems that can mimic human decisions, you can better understand what different interventions would lead to in terms of the impacts to people. So pretty cool.
Yeah, it's really interesting. I know the storm chaser community loves their safety discussions, so maybe at some point we'll get one of those available. So if we fortunately, hopefully we never have another storm chaser accident, but I know with some of those accidents they put together the PowerPoints. Maybe we'll see some of those AI-driven discussions in there, kind of showing if we were to have a hypothetical storm similar to El Reno, how would storm chasers behave around it?
Right, and hopefully lead to more safety, because ultimately there are some decisions that we can make that can turn out poorly, and then there are decisions that are just beyond our control. And we've unfortunately seen too many of those true accidents take place, and it sucks. But let's not drown all the buzz.
Yeah. All right. Well, with that, we have seen some very, very interesting stuff courtesy of Dr. Evans tonight. So I want to extend my thank yous for you coming on the show this evening. And the future, I think, is very, very bright for the upgrades to some of the forecasting systems that we have in place, and for new tools that may be available not only for storm chasers but for meteorologists all throughout our field, kind of coming down the pipeline here soon. And maybe one day we'll be using AI to just kind of pick out storms for us that we don't even have to forecast.
Yeah, I hope that day does not come, because I like job security, and AI taking our jobs, I don't think I want that. I'm not sure that you necessarily want that either, getting into this field. But I think it'll be great to help us make even better forecasts, give us tools to make those better forecasts. And yeah, thanks so much for allowing me to come on tonight, Charlie. I really appreciate it. And thanks to everybody who's tuning in live, or if anybody's catching the recording, thanks for tuning in. And if you got any questions, feel free to shoot them our way.
Yeah, absolutely. Fortunately, the day of AI replacing us completely is down the road a little ways. You can't replace the pattern recognition and intuition that is the human mind.
Yes.
But before we wrap up entirely, we haven't really read chatted a lot tonight, so I want to turn things back to our live chat right now. If you all have any final questions before we wrap up this evening, we'll be happy to answer them here over the next few minutes and just kind of chat around a little bit, see what everyone's doing. I see Cade down in chat right there. How's it going, Cade? Thank you for tuning in this evening.
Yeah, thanks for tuning in, Cade. Hope you're enjoying watching a little bit of hockey before it goes completely away for the season.
Yeah, it might take a little bit for questions to start trickling in, but I'm really interested to see if these will become available within the future. If you have any knowledge of for the storm chasers and meteorologists watching right now, do you have any idea at all of when these products might become available to use, or are they still a little bit down the road?
It varies. Some of them you can actually access now. Everything that I included in the presentation tonight is on a public website, so you could access all of those things at this point. But the long-range machine learning product is one out of Colorado State. They've been running for a few years. You can get that online, or the Warn-On forecast system. If you just search that online, you can get that as well. But some of the changes to the SPC's products themselves, those will take a little bit more time to filter through. They've got to go through a lot of evaluation, then they have to be approved at multiple levels within the government before they can actually take effect. So those will be a little bit longer in coming, but the model tools that exist out there, a lot of those you can get at today. And of course, NATOcast, that's available on social media and through the SPC's website too.
Mm-hmm. I know the storm chasing world loves NATOcast, seeing that pop up. I remember the high-risk day they had in May down in Oklahoma. NATOcast was completely off the rails for that day, and I know Twitter loved seeing that.
Yes, anything extreme, hashtag extreme, whether it verifies or not, really draws a lot of attention.
Mm-hmm. K-Zone chat. Being recognized, one of the first things brought up is hockey. This is unbelievable. Great show, though. Thank you for tuning in, Cade. Great to have you in here tonight. Gary Sorensen is asking, please define discrete as used by meteorologists with respect to severe storms.
Yeah, for sure. So discrete means like isolated. So instead of a bunch of storms congealed together in some sort of line type of structure, you're looking at one storm here and then another storm separated by it and then another storm. Yeah, Charlie, if you want to take it here.
Yeah. So, sorry, I don't mean to steal the thunder a little bit, but this is just a little bit of a example. We have, this is a discrete storm. The storm is by itself, kind of isolated alone. And then non-discrete storms will look something like this, where we have that those big lines that you often see in the summertime throughout the Midwest.
No, that's a great question. And oftentimes us meteorologists, we get our own lingo and then think, oh, everybody knows that lingo. And we have to take a step back and be like, no, everybody doesn't necessarily know that lingo. We're the weird ones. So let's step back and explain it. So thanks for that question, Gary.
Yeah, I know sometimes I get caught up with the lingo when I'm explaining whether I'm like, oh, we have this storm environment today. There's like 3,000 CAVE that can help fuel storms. You're like, what does that even mean?
Now we've got all our models with all our acronyms, GEFS and HER and HREF and Rufus. Meteorology loves its acronyms.
Mm-hmm. Some acronyms are more creative than others, though.
Yes, which I had a proposal for a field program where we were going to try to study MCSs interacting with Lake Michigan. And my colleagues and I came up with MOMI, modeling and observations of MCSs in the mid-latitude maritime environment. But a couple of our colleagues thought that that was not professional enough, and so we had to go away with MOMI. But I thought it would have been a great name for a meeting or for a field program.
I don't know. I think some of the funnier names make the research more memorable. People kind of pick up on it a bit more, like, oh, okay, this is a bit more unique. Maybe there's something to this.
Yeah, there was a field program in northern Wisconsin up in the Northwoods a few years back called Cheesehead, or Chi was Shawamigan. I forget all of the rest of it, but it was measuring atmosphere, land, and exchanges up there. I loved the name Cheesehead.
I want to have a research project named Cheesehead. We need one of those.
Yes, for sure.
Cecilia is wondering, will you be chasing this Saturday? I might be out this Saturday. Depends when I get off work and kind of what I have going on in the evening. Dr. Evans, are you going to be out chasing on Saturday by chance?
Most likely not. I've got a bunch of people coming over here before I leave Wisconsin, and so I think I owe it to them to be a good host rather than hit out on the roads. It is intriguing with that slight risk here, and even tomorrow with the moderate or marginal risk nearby. But no, I probably won't be.
Mm-hmm. Don't want to take them on a little storm chasing party. One last hurrah in Wisconsin.
Yeah, if there was something really close by, I remember in spring 2020, we had one. I'm in Ozaukee County, and we had one right coming from Washington County into Ozaukee County. So we just headed up Highway 33 and saw what we could see, and that was that. So if there's something like that, yeah, maybe. But beyond that, probably not, unfortunately.
All right. Well, I'm not seeing any more questions popping up in chat tonight. Maybe we'll give it another minute or two. But before we conclude, Dr. Evans, do you have any closing statements before we wrap things up this evening?
I don't think so. Just thanks again for having me, Charlie. And yeah, I hope this is exciting and interesting for everybody who's tuned in or might tune in the future. And I know you got it on the next slide, but hit that like and subscribe button.
Yep, you've taken the words right out of my mouth. Thank you all very much for watching. Greatly enjoyed having Dr. Evans on the stream tonight. Thank you once again for joining us on this evening's show. It was really, really intriguing to take a look at what the future of severe weather forecasting might look like with some of these new tools coming down the line.
Yeah, thanks again for having me, Charlie. And thanks again to everybody for watching. Have a good night.
Yeah, once again, turning things back to the audience, thank you all for tuning in this evening. It was a great show. I hope you all enjoyed Dr. Evans coming on and showing us some of this new stuff that's a work in progress and maybe hitting the forecasting scene near you soon. So once again, final thank yous. Thank you, Dr. Evans, for coming on the show tonight. And it's hope you all have a great evening and stay weather aware this weekend with some of the storms we might have coming up. All right, well, with that, we are going to close things out. So final thank yous. Thank you all again. All right. And